All right, in this lesson, we're going to go through representations of equations. We've already looked at this once before. We're going to spend a little bit more time working through these as it relates to reactions, and we've looked at net ionic equations as well in this unit where ions get split up. Okay, so let's start with the actual reaction. So it says C2H4 reacts with oxygen, O2, to form CO2 and water. CO2 and water. And that's my dog. All right, let's split this in half. We have carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. On the left side, 2 carbons, 4 hydrogens, 2 oxygens. On the right side, 1 carbon, 2 hydrogens, and be careful, we actually have 3 oxygens. Okay, there's oxygen in 2 places. All right, let's start by balancing our carbons. Okay, so 2 on the left, 1 on the right. Let's put a 2 here. Remember that distributes to both terms, so that'll make this 2. 2 times 2 makes this 4, plus the other one, 5. Okay, now we need to balance our hydrogens. We have 4 on the left, 2 on the right. Let's put a 2 here. That 2 will go to the hydrogen and the oxygen. 2 times 2 is 4. 2 times 2 will make this 6. And then to get 6 oxygens on the left side, we need to put a 3 right here. Okay, so that's balanced. Okay, unfortunately, that's not what the question was asking us to do. The question was asking us to draw a particulate diagram. Okay, so let's split this up. So we have, if you look at our balanced chemical reaction, we have C2H4. Okay, I'm going to use some dots here to represent. So let's do red for carbon. So we have 2 carbons, and then we have 4 hydrogens. So 1, 2, 3, 4. And then we have 3 O2s. So let's make oxygen blue. Now it's O2, so they go together. All right. And obviously these are being added together. Okay, on the other side of our reaction, carbon is going to go with oxygen. Okay, so on the right side we have carbon. We have 2 of these. And oxygen. There's 2 oxygens in each one. Sorry, those don't exactly match up. There we go. Perfect. All right, and then we have 2 H2Os. Okay, so hydrogen was a little, we need oxygen. 2 oxygens. And then we are going to have our little hydrogens attached there. Just like that. Okay, now we're going to balance this the same way. So let's take a look at all of the dots that we have on both sides. The important part is you see that we're conserving here. Okay, so the number of particles is the same on both sides. So on the left side, we have 1, 2, 3, 4. We have 1, 2, 3, 4, 5, 6 blue dots. We have 2 red dots. On the right side, we have 4 of our little black dots. We have 2 of the red dots. And we have 1, 2, 3, 4, 5, 6 of the blue dots. Okay, so all of the ions are conserved. So you need to be able to draw a particle diagram. I did it with colors this time. The next time we're going to do it a little bit differently. Chances are when you're taking the test, I can say with absolute certainty you're not going to have a cool touchscreen monitor with colors. We're going to be doing it with black and white pencil. So on the next one, I'm going to do it black and white, just like you're going to be doing on the test if you have to draw one. The only reason I use colors this time is so that you can see easily that the particles balance. So let's take a look at the next one. It says barium metals burn in air. Make a particular drawing showing which atoms are conserved during this reaction. So barium is Ba. Let's use black. Okay, so barium is Ba. And you're burning it in air, which is O2. And they're going to combine. Barium is +2, oxygen is -2, so it'll be BaO. To balance this, I need a 2 here to get 2 oxygens, and then I need a 2 here to get 2 bariums. Okay, so as promised, let's do this with just black and white. Barium. Okay, so I'm going to use circles here, Ba for barium. Those are separate. I have 2 separate bariums, and then I have O2. O2 is together, just like that. That looks like a cool 8. All right, on the other side, we have BaO. We have 2 of them. Okay, so if you notice, this barium is going to hook up with this one's going to hook up with that one right there. So when I draw this on the other side, we'll have barium and oxygen, and then we'll have barium and oxygen, just like that. Okay, and if you notice, all of the particles are conserved. Okay, so I have 1. Oops, that's not a check mark. Let's try that again. I have 1, 2, 3, 4 bariums, and then I have 1, 2, 3, 4 oxygens. Okay, so 2 bariums on each side, 2 oxygens on each side. Everything is conserved here. All right, let's move down to our last example here. It says bromine reacts with potassium iodide. Make a particulate drawing, show which atoms are conserved during the reaction. Okay, so let's write out our equation. You've got bromine, Br. Bromine is one of the diatomics. It always has to have a buddy, so Br2. Potassium iodide is Ki. Make a particulate drawing, so this is going to be a single replacement reaction. Barium, sorry, not barium, that was the last one. Bromine is -2. It's going to switch out with the iodine, which is -1. Bromine is not -2. Bromine is -1. All right, so potassium and bromine will go together, KBr, and then you're going to have iodine by itself. Iodine is diatomic. It always has to have a buddy. And then to balance, I need 2 iodines on the left side, so I'm going to put a 2 here. And then I need 2 bromines on the right side, so I'm going to put a 2 here. Okay, so let's draw our particle diagram. So we have bromine. There's 2 bromines together. It's Br2. And then we have potassium iodide. Okay, so those are going to go together. But we have 2 of them. Potassium iodide. Potassium iodide. Okay, that's on the left side. On the right side, we are going to have potassium and bromine go together. We're going to need 2 of those. Okay, so basically these are just hooking up right here. And then we're going to have iodine by itself, but remember iodine is diatomic. Iodine always has to have a buddy, just like that. Okay, so those are 3 examples of particle diagrams. You're going to be working through a couple of these now. Just make sure that you've got the same number of particles on the left side and the right side, just like when we balance equations. All right, good luck.